All right, we shall continue on then. Okay, just maybe I'll just start off with a few questions. Review. When I ask you a question, don't shout out the answer, because if you shout out the answer, then other students who might have taken a few extra seconds to figure out the answer might not have the opportunity to think of it. So think of the answer, but don't shout it out, and then we'll go over the answer. And so let's see. Okay, so if you were to see a histogram, okay, if you were to see a histogram like this, don't shout out the answer, but how would we describe the shape of this histogram? Okay, so just think of the answer. You can think of the answer or write down the answer, whatever. And there's two words I'm looking for. Two words. Okay. The first is regarding how many peaks. Okay, so somebody who has their hand up, what would that be?
One peak, so it's
Unimodal, all right. So this is describing the shape. We would say it is unimodal. Okay, and then the other is regarding the skew or symmetricity. What's that?
Right.
This would be right skew. Good. Okay, again, don't shout out the answer. Would this apply to numeric data, categorical data, or both types of data? And the answer is numeric data. Numeric data only. Okay. And again, don't shout out the answer, but once again, this type of graph is called a histogram. Histogram. Don't shout out the answer, but just think of these answers in your own mind. Yeah. Okay. So this is a histogram. Good. All right. So on the other hand, so we looked at histograms, and that's for numeric data. Categorical data can be summarized, and just think of what kind of graph we can use. So what kind of graph can we use? Don't shout out the answer, but what is the name of the graph that we would use to display categorical data? It might look something like this. Alright, and this is called a bar chart. Bar chart. Some differences between histograms and bar charts. Try to think of some in your own head. What are some differences? Okay. One is the gaps between bars. Again, that's a stylistic thing. But the main difference is that the order of bars in a bar chart doesn't matter. Any order of bars is valid. All right, let's go back to the histogram. Don't shout out the answer. What does the height of the bar signify? So this bar is tall, this bar is short. What does the height of the bar signify? In the back. I'm sorry?
A number.
The height does not signify a number. I mean, in the most basic sense, but But what does it mean for this bar to be tall and this bar to be short? Not quite.
Value?
Not the value, no.
Radiation?
What? Okay, I think we're just shouting stuff out. The frequency. The frequency. Tall bars mean this. Okay, the height represents the frequency. Okay. So this bar is the most frequent what? Frequent, not an occurrence. Well, I mean, yeah, frequent occurrence. But what are we talking about here? If this is a numeric variable, yeah, the most frequent value. Okay, so whatever value we have here, this is the most frequent value. So if this is, we're talking about, I don't know, maybe in a high school, somebody you measured people running the mile. Okay, maybe this is eight minutes. Okay, or something between 8 and 9 minutes. That might be the most frequent time. Okay. All right. What does this bar represent? Okay, less frequent. But what does it signify for the bar to be over here? Huh? Not an outlier, no. Okay, what? Yes, you. Huh? No, I mean, well, any of these that have short bars are less frequent. Okay, so let's say this is mile run times. Okay, so this is 8 to 9 minutes. That bar, and then we probably have something over here also. Okay. So these are people who run the mile in 7 to 8 minutes, 6 to 7 minutes, and maybe 5 to 6 minutes. Okay. People over here, what does this mean?
Or slower.
Yeah, this person took a long time to finish the mile. Okay. The fact that it's on the right side, this means we have larger values, or basically a slow run time. And the fact, so the position of the bar, whether it's to the left or to the right, tells you something about the value that the bar represents, and the height of the bar tells you how common that value is. Okay? So the height represents the frequency, and then whether it's left or right tells you about the value. Value determined by going left or right. So low numbers are over on the left, high numbers are on the right. So this is somebody who took 16 minutes to finish the mile. All right? So just walking leisurely. Okay. But yeah, mile run times might look something like this. So you have a peak. Most students finish over here. Some are faster, but you don't really have very many students finishing the mile in under 5 minutes. Okay. I think the world record for a mile is just under 4 minutes. Okay. So you're gonna have nobody under that significantly under 4 minutes. I guess in high school you might have some high class runners, but like that, and then you're gonna have a few students who take a long time to finish. Okay, is that okay? I want to, of course it makes sense, but when I explain it, but you've got to be able to look at a histogram and then be able to draw out meaning from it. All right, let's talk about a bar chart then. is a bar chart. And here we're dealing with categorical data. Alright, and what does the, don't shout out the answer, but what does the height of the bar represent? What do you think the height of the bar represents? And the height represents frequency, just like it does over here for so the height represents frequency, just like it does for histogram. Okay. Could we describe the shape of this bar chart? What would you say? Okay, so who thinks you might say this is right skewed? Okay, no, that was a trick question, okay? It's a bar chart, categorical data. This is not right skewed, okay? Why can we not call this right skewed? The reason why is the order of the bars is arbitrary, okay? So just as, so maybe these are, I don't know, what, maybe what cell carrier you use, right? Okay, and this would be like Verizon and AT&T and T-Mobile. Maybe I don't know. Actually, so and then Sprint or something, and then this would be some other, right? Okay. So it looks like it goes like this, but the order of the bars don't matter. I could go alphabetical order, and I would go AT&T, Sprint, T-Mobile, Verizon, and then other. And so these represent the same data, so you would not call this right skewed, and you would not call this right skewed either, okay? The order of the bars don't matter. What does it mean that this bar is the tallest? What does that mean? Go ahead. Highest frequency, okay? So this is our survey of who's your mobile service provider. And people who answered Verizon, that was the most common category, okay? So this would be, this is the most, so again, height represents frequency, so Verizon is most common, et cetera, et cetera. There's this notion of variation, okay? So this is a bar chart representing some categorical variable. Let me just exaggerate this one a little bit more. Okay. Which of these bar charts exhibits let's see. How do I All right, which bar charts exhibit more variation? More spread? Left or right? Left or right? This one has more variation. Okay. And it's even if these ones were all different heights, okay. I kind of ended up making them all the same height. But how do we define variation over here? Okay. Here we have one category kind of towering over the other categories, okay? So the fact that most people fall in one category means there's less variation, okay? Over here, the fact that the bars are closer in height, okay? Actually, now that I show three bar charts, which one would show has the most variation? No, this one has the most variation. Okay. Why is that? We're not looking at the height. I mean, we are looking at the heights of the bars, but even here that all the bars are the same height, that's not. We're not worried that the bars are the same height. Okay. Remember, we're thinking of the underlying data, which is a categorical variable. Okay? So, let's think of racial diversity. Okay? Racial diversity. Let's pretend we go to Nebraska. Okay? Alright, so Nebraska, most people in Nebraska are white, are Caucasian, okay? And then, and you have minorities there, okay? You probably have some Hispanic Latino, okay? Some black or African American. Asian, and then actually in Nebraska you have Native American, quite a bit, and then other, or whatever, okay? But in Nebraska, would we say Nebraska is known for its diversity? Racial diversity? Probably not, okay? Alright? You go somewhere else, alright? You come to Los Angeles, alright? And Los Angeles, I think the largest demographic category is now Latino. All right. Just recently, I think maybe it's very. I mean, well, the category, racial category white is always they split between non-Hispanic white and Hispanic. So I think Latino, Hispanic is the largest, and then non-Hispanic white, followed by Asian and African American and other. All right. So this might be Los Angeles. Okay, quite a bit of racial diversity in Los Angeles, something like this. All right, and this would be where all of the different races are equally represented, okay? Are equally represented in this situation. So this might be like I don't know, the United Nations Council or something, right? Some selected committee for promoting racial equality or something like this, right? This is all categories equally represented. Okay, all of them have equal frequency. So of these, which one, now that you can imagine the people groups, which one has the most diversity by our set of the one where they are all equally represented would be the one with the most most variation or most diversity. Okay, so you could think of when it comes to categorical variables, think of I think our brains work a little bit better if we can relate it to something, because the word variation just feels a little odd. But if you can think of like, oh, if I think of a city and its racial diversity and imagine what a bar chart might look like, then that might give you an idea of the variation that exists. So for the category race or ethnicity, okay, variation is similar in idea, similar to diversity. And this actually works. It works well for the United States because I think we're more used to the idea of variation. Whereas you go to other countries around the world, and you don't have as much. You don't have as much diversity. Okay, the populations are much more homogeneous. There's well, and everything comes with its pros and cons. Okay, is that all right? The concept of variation for categorical variables. Okay, so that pretty much wraps up chapter 2. You got a little bit of reading in there, talking about just things to watch out for, misleading graphs, etc., stuff like that. Make sure you do your reading and do your homework. I hope the homework exercises are of use, are beneficial to you guys. Okay. Okay, so we're going to go back now to numeric variables. Okay. So that was categorical variables. Now we're back to numeric variables. And this is now chapter 3. And we're going to look at numeric summaries. Okay. So numeric summaries for numeric variables. Summarizing numeric data So the idea behind chapter 3 is that we've taken a sample and just think of what that word sample means. And what is a sample? What's that? A sample is a selected group, okay? A sample is a group of data that we have selected that comes from the population. The population, once again, is everything that we could possibly want to study, but we don't have the resources to study everyone. Okay? So we don't have the resources to study everyone. So we select a sample, and we study the sample. But in that sample, we still might have 400 people. Okay? We look at 400 people. Now, somebody might ask you, okay, well, what were the people like in your sample? Or maybe you're interested in, something about these people that you've studied. Well, you don't want to say, oh, well, the first person I met, her name was Anna, and she was 35 years old. She has 3 children and this and that. And then the next person I met, his name was Carl, and he was 63 years old, etc., etc., etc. And you don't want to go and explain all of these things for 400 people, right? You just want to be able to provide some summaries, right? They might say, okay, well, you looked at 400 people. They might ask you, what can can you summarize anything about their age? Okay. Well, to summarize numeric data, whenever you've got a good amount, we're going to use statistics. The concept of average is a statistic, okay? It's just a single value, it's a number that summarizes the entire group of 400. You might say, what was the average age of your sample? And you might say, oh, the average age was 38 years old, okay? And that gives you an idea, oh, okay, that was the average. Some people are going to be older than that number, some people are going to be younger, but the average age in my sample was 38 years old, okay? It doesn't tell you too much, but it just summarizes all 400 people into a single number. And those are sample statistics. So statistics, there's different meanings to this word statistics, but one meaning is basically values that we can calculate from a sample. Take a sample, and from that sample, we can calculate statistics. Alright. And these these statistics, we can group them into two general groups. Alright. When we are describing numeric data, we can create a histogram and we can get a picture of it, but if we want to summarize it with just numbers, some statistics, all right? Can summarize, and the ones that we are going to learn about can summarize center. Okay, center being kind of where the middle. What is like what are typical values? Okay, summarize center, and so these are. So usually when you think of center, you'll think of the word average, okay? Or this is, average is a notion of center, okay? And the two values that we're going to learn are the mean and the median. These are ways to summarize the center of a distribution, or center of numeric data. You'll hear this word distribution. Okay, so just an aside. Distribution. What does you can shout out the answer. What comes to mind when you think of the word distribution? To give out, okay. You think of. I used to work for UPS. I think of like these distribution centers where the packages go out. Okay, so here a distribution. This tells you how. Remember, in your data set, maybe there's 400 people. All 400 people have different values for their age, right? Some people are going to be 20, some people are 40, some people are 60. You know, you might have multiple people who are 40 or something like that. But all 400 people, they've got different values, and the distribution tells you, you know, which ages are most common, which ages are less common. It gives you an idea of how those ages or how those numbers are distributed. Okay? So it tells us how the data values are distributed, okay? But a lot of times we kind of use it interchangeably with the idea of used almost interchangeably with a data set from a sample data set. Numeric distribution, you can just think of it as numeric data set or just a set of data. And so statistics, sample statistics can provide us ideas of the center. We'll learn about the mean and the median. And they will also tell us about the spread. Okay? Also the spread. Okay? And the spread tells us basically whether the numbers are similar or vastly different. Okay? Are the numeric values similar to one another or very different? Values there are we have range, we have interquartile range. I'm going to just summarize with IQR. We have the standard deviation, and variation. So all of these numbers, there's 4 of them, or 6 of them. The mean, the median, range, IQR, standard deviation, variation. These are all sample statistics. So they are all values that we can calculate from a set of data. And they are single numbers, okay? They basically tell you an aspect about that data using a single number. Alright, so let's talk about our notions of center. Now, the book splits these things up. I split them up as numbers that summarize center and numbers that summarize spread. The book splits them up as numbers that are useful for symmetric distributions and numbers that are useful for skewed distributions. And there's nothing wrong with splitting the numbers up that way. But the truth is, these numbers can be calculated for any set of numbers, for any set of data. So the book might say, this number is useful for symmetric distributions. But the truth is, the ones that the book labels useful for skewed distributions can also be used for symmetric distributions. Okay, so no matter the shape, we can still calculate mean, median, range, IQR, standard deviation, variation. Okay? These numbers, however, they can only be calculated for numeric variables. We cannot calculate these for categorical variables. Okay, so only for numeric data. Okay, so statistics that summarize center, all right? So the idea of center is the idea of what are typical values, okay? What's the kind of the central value that that we might see in this distribution, okay? Where is the central values, or central value, or what is a typical value? Okay. But center only tells us part of the picture. But let's just talk about these quickly. So the mean, we find, you've probably learned this in elementary school or junior high. You add up all of your numbers and you divide by how many you have. Okay? Add up the numbers, divide by how many you have. Okay? The symbol for mean is x bar. Okay, so x representing the value and the bar over it. That's the symbol for sample mean. And the formula is summarized as this. This is the Greek letter sigma, which means sum. Okay, so sigma means sum or add up. X means add up the x's, each value that you have, and n is your sample size. So however many numbers you have, that is n, the number of numbers. That's n. Okay, that's okay, right? No one's too scared of this formula? Equation looking thing. If you don't like the way equations look or formulas look, you don't have to use them. You just have to know, add up the numbers and divide by how many you have. Okay? You do need to know that x bar represents sample size though. Okay? You don't need to know this. You can hide this if you don't like it. But you do need to know x bar means, x bar means sample mean. And n means sample size. Those are extra. You do need to know that. Yep, the rest not as important. Median, the median is the middle number. This is literally the middle number. Okay, or middle value. This is half of the numbers in the data set are larger than the median, and half of the numbers in the data set are smaller than the median. So half of the numbers are larger and half are smaller. That is the median. Okay. The median is also known as the 50th percentile. Are we familiar with the term percentile? Percentile, whatever number is the percentile, it means that percentage is smaller than that percentile. So the 50th percentile means that 50% of the data is smaller than the 50th percentile. Okay, so for example, when it comes to the height of US females, the 50th percentile is about 5'4½". Okay? About half of US women, 50% of American women, adult women, are shorter than 5'4½". And 50% of women are taller than 5'4.5". Okay, so that's the 50th percentile. 50th percentile is the median. It means 50% of data or people, 50% are less than this value. Okay. At the 30th percentile, what percentage of people have values smaller than the 30th percentile? 30%. Okay? And you can shout this out. At the 30th percentile, what percentage of people have values larger than the 30th percentile? 70%. Okay, good. So if somebody says they scored in the top 5%, that puts them in what percentile? The 95th percentile. Okay? So if you are in the top 5%, you are in the 95th percentile. And if you're in the bottom 5%, you are at the 5th percentile. Okay? Or lower. Okay, but I want to show you what is that the notion of center doesn't capture everything. Okay, so we can talk about center, and we can look at the mean. And okay, so let's say you got you have I don't know, you have a group of 7th grade students, okay? So you have a group of 7th graders, okay? And let's say their ages are 12, 12, 12, 13, 11, okay? What is the mean age? Okay, you add them up and you divide by 5 and you get 60 divided by 5 and you get the mean age is 12. Okay, so far so good, right? Okay, let's say you have a group of students, so I don't know, maybe there's a private school that's K through 12, okay? Group of 5 students at a K through 12. Alright, and let's say the students there, we have a 12-year-old, a 16-year-old, a 10-year-old, an 8-year-old, and a 14-year-old. Okay? What is the average age of this group? 12. Okay? Mean age, you add them up, you get 60 over 5, and you get 12. Okay? So both of these groups have the same mean age. Alright? So if you just looked at a single number summary of the group, you might be mistakenly led to believe that they are that they're similar. Okay? Because the ages, the average age or the mean age is the same for both groups, right? Okay? But the groups are very different, right? I don't know. Okay. So you've got so the mean tells us about the center, but it doesn't tell us about the spread of the groups, okay? And then so the notion of center doesn't capture the whole picture. To get a little bit of a better picture, we would also need to include numbers that describe the spread, okay? And what we would see is that numbers that describe spread would say this group has small spread and this group has a larger spread, Is that okay? So we also need to talk about spread, and over here we would see small or little spread, and over here we would see large spread. Large. That's just that's the meaning. Before we move on to talking about the spread, let's talk about finding the median. Is that okay? Okay. So the median is just the middle point. You got to figure out where half of the numbers are larger than that middle point and half are smaller. Okay. So for this group of 5 students, what would the median age be? 12. Okay. Because if we arrange these, so let me so to find the median, your first thing is to arrange the values from least to greatest. Alright, so we would do 8, 10, 12, 14, 16. And when I lay the numbers out like this, it's very easy to see that this is the middle number, and half of the numbers are larger and half are smaller. Okay? It's very, very easy to see that. Okay? But if you have a lot of numbers, so in this case the median is 12. But for larger sets, and I'm just going to delete this, or erase, is that if it's not obvious what number is the median, okay, the median is the number in the n+1/2 position. Okay. Yeah, you have a question?
What if we have an even amount of numbers?
Okay, yeah, we'll talk about that also. All right. Okay, so just going back to our first data set, using the same number 8, 10, 12, 14, 16. Okay. What is n? N is the sample size, so go ahead, shout it out. N is 5, right? I've got 5 numbers. N is 5. So what is 5 plus 1 divided by 2? 6 divided by 2 is 3. So I'm going to find the number in the third position, okay, or third. So this is first, second, third. This is my third number. That is my median. Okay, it works for 5 numbers. It'll work for 200 numbers. Okay, anything in between, and anything in between.
But you still have to put them in order.
You got to put them in order from least to greatest. If you don't do this first step, the second step is going to be wrong. Okay? If you don't do the first step, the second step is going to be wrong. All right, so let's try it with a larger data set. Okay. Okay, so let's say we're still picking students from the K through 12, okay? And so let's say we have, we get a bunch of different students. Okay, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I've got 12 students there. Okay, an even number. So the first thing we have to do is we have to arrange these numbers from least to greatest. Okay. So I'm working at the board, so sometimes it's hard to catch your own mistakes. So if you see I'm making a mistake here, please call it out. I hope this is arrange these from least to greatest. This is step 1. Alright, and you can shout it out. What is my n here? 12. I've got 12 numbers, so n is 12. And what is n plus 1 divided by 2? 6.5. So n plus 1 over 2 is 13 divided by 2, 6.5. Everyone's with me so far? Just nod your head if you're doing good. Okay, 3 of you nodded your head. Okay, so we're going to find the number in the 6.5 position. Okay? So a common mistake is people will say my median is 6.5. My median is not 6.5. This only tells me where my median is going to be. Okay, so I'm going to label these. This is 1, 2, 3, 4, 5, 6. This is my 6th number, and 11 is my 7th number. And this is 8, 9, 10, 11, 12. That's the 12th number. Okay, so if I order these from least to greatest, 10 is my 6th number, and 11 is my 7th number. Okay, so the 6.5 number is an imaginary value that lies halfway between 10 and 11. Okay, so the 6.5 number, it's an imaginary number, or not imaginary, but it's an imaginary value that lies halfway between 10 and 11. So what number is that? 10 and a half, right? Okay, so our median is 10.5. Now, it might not be obvious if, in this case it was easy because it's 10 and then 11. It's easy to see that 10 and a half is halfway in between there. But if you have two values, let's say your middle two numbers were 23 and 41, what's halfway in between 23 and 41? Well, that's a little bit tougher to do, okay? So if your middle two numbers, let's say your 6th number was 23 and your 7th number was 41, what's halfway in between here? Well, you do 23 plus 41 divided by 2, okay? So you just take the mean of those two numbers, all right? And then so you get 64 divided by 2, it's not 36, 32. Okay, so halfway between 23 and 41, your median is 32, okay? And so that means I've got 5 other numbers here. It could be 5, 4, 3, 2, 1, and these could be 43, 44, 45, 8, 9, 11, 15, okay? It doesn't matter. If these are my 12 numbers, my median is 32. Okay, because this is 12 numbers arranged from least to greatest, 6th place, 7th place, halfway in between, 32. So my median here is 32. Is that good? All right. Okay, so now that you've learned medians, I can teach you another concept called quartiles. Alright? So the median divides our list into, it finds the halfway point where half are smaller and half are larger. Okay? Quartiles, basically there's going to be 3 dividing spots, and it divides our set of data into 4 pieces. Okay? So imagine you've got a bar of chocolate, or you can imagine just on your fuel gauge, if there's 3 lines that divide your fuel tank into quarters, right? So the first quartile is going to be the spot that separates 1/4 of the smallest 1/4 from the bigger 3/4. Okay. The second quartile separates the lower 2/4 from the upper 2/4. And then the third quartile splits the lower 3/4 from the top 1/4. Okay? So the second quartile is also known as the median. So we rarely call things the second quartile, and we'll usually just say the median. Okay? So Usually when we talk about quartiles, we're referring to the first quartile and third quartile. Okay? So, how should we find the quartiles? Well, once you find, the first step is finding the median. And once you've found the median, you just look at half of the list. So here I got 12 numbers. My median splits the lower 6 from the upper 6. And I'm going to just find the median of these 6 numbers. Okay? And then to find the third quartile, I take the upper 6 numbers and I just find the median of those 6 numbers. Okay? To find the median of these 12, I just look at the lower 6 and take the median. That's going to give me Q1. And over here, I'm going to take the upper. Okay, so on your own, see if you can identify Q1 and Q3 for this set of numbers, and Q1 and Q3 for this set of numbers. Okay, so I'm going to just write this up here. So we've got Q1 is the first quartile. Okay, 1/4. Whoops. Here, I'll write this down. 1/4 is smaller. And Q3 is the third quartile. 3/4 is smaller. 3/4 of the data. Okay. To find quartiles, first find the median. And take half of the list, or half of the numbers. And then find the quote median of those numbers. Okay, so go ahead and see if you can find Q1 and Q3 for this set of numbers and Q1 and Q3 for this set of numbers. And I'll give you guys a few minutes to do that. Just wander about. Yeah, for both lists of numbers, the list on the left half and the list on the right half, we can find Q1 and Q3 for both ones. Right now, I'm taking it. Okay. Good. You know,
So it's 32. Right,
Yeah.
62. The median is 32.
Sorry, 32. But 4 part we have to be here, right?
It'll be 4 because here's 1, 2, 1, 2. It's like right here.
Yeah.
I don't know what happens when it's
So we get
It's hard to compare when you have 5 categories versus 4 categories.
First quarter, this one.
Yes, it's more. It's tough to say. General.
First quarter.
It's like you find the median of the whole thing, and then you find the median.
Okay, how are we doing? How are we doing?
What? The half, two halves.
Okay, just go ahead and call them out. Q1 over here is 3.5. Q3 is 44.5. Q1 over here, 8.5. Q3 over here, 13.5. Okay? Is that good? Yay. All right. Okay, so again, first, so we'll do this one. If you didn't get it, first step is you find the median. So we've got 12 numbers. The median is going to be the 6.5 number. So we find the 6th place, 7th place number, and we found that the median is 32. Okay. Now I've got 6 numbers. I'm going to look at just this lower 6, and I'm going to find the median of these 6 numbers. So now I pretend my n is 6. 6 plus 1 over 2 is what? 3.5. Okay? So this is my first, second, this is my third number. This is the 4th number. So halfway between 3 and 4 is 3.5. This is my Q1. I do the same thing over here. I've got 6 numbers. N plus 1 over 2 is 3.5. So I go 1, 2, 3. This is my third number. This is my 4th number. So Q3 is going to be 44.5. Is that okay? All right. And then, just to go back to the definitions of what the first quartile and third quartile are. All right. How many numbers do I have total? I've got 12 numbers, right? What is 1/4 of 12? 3, right? So 1/4 of the data, 1/4 of 12 is 3. So 3 numbers should be smaller than the first quartile. Is that the case? This is Q1, Q3.5. How many numbers are smaller? 1, 2, 3. Okay? What is 3/4 of 12? That's 9, right? So 9 numbers should be smaller than Q3. Is that the case? 44.5. How many numbers are smaller than 44.5? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers are smaller than Q3. Okay? That's 3. 3 numbers are smaller than Q1, which is 3.5. And over here, 9 numbers are smaller than Q3, which is equal to 44.5. We do the same thing over here. It's easy when there's you got 12 numbers. So here I've got 8.5 is Q1. 3 numbers are smaller than Q1. And over here, my Q3 is 13.5. Okay. Is that okay with everyone? So we have the mean and the median. Q1 Q1 and Q3. Yes.
Maybe you're doing it next.
Go ahead.
If there's not an even amount of numbers.
Okay. So okay, so if we have an odd amount of numbers, it gets a little bit confusing when it comes to finding quartiles, okay? And we won't worry too much about it, okay? Basically, there's debate as to whether you should use the middle number in finding the quartiles, and the unfortunate thing is, if you read different textbooks, they'll say different things, okay? So, some people say do or don't include it, okay? And it's just like, I don't know, you go to different, what's another example that's common, but basically, depending on who you ask, finding Q1 and Q3 varies just ever so slightly when you have an odd number of numbers, okay? It's not, it's unfortunate that it goes that way, but whatever, okay? Alright, so we won't worry about that. If I ask you a test or quiz and find you Q1 and Q3, it will, there will be an even number of numbers, and you will be able to find Q1 and Q3 easily, okay? Okay. So, you could practice, like, make up a list of 14 numbers, see if you could find Q1 and Q3, things like that, okay? 10 numbers, 12 numbers, 14 numbers, any even number of even number of numbers. Okay. Let me just make sure I'm doing okay on time. Okay. So now let's talk about measures of spread. Okay. Alright, so measures of spread, okay, or these are statistics, sample statistics for spread. So I'll accept these today, but in the future, make sure you turn them in at the beginning of class. We'll see you later. All right. Measures of spread and sample statistics for spread. So here, we've already mentioned these. We've got the range and the IQR, and then we have standard deviation and variation. Okay? And just like when we talked about the mean and median, it gives us an idea of where the center might lie. Okay? Just like what's the average age for the 7th graders, or what's the average age for the group of students from the K through 12. Measures of spread give us an idea of how spread out the numbers are, or how close together our numbers are. We have a question back there.
Let me go off rails. You want those homework completions at the beginning of class?
Yeah. I'll set up, at the beginning of class, I'll set up some piles, turn in your homework completion pages at the beginning of class, okay? This week we'll let it slide, but probably starting next week, after the first few minutes of class, I'll gather them up and put them away. So just make sure you get your homeworks in at the beginning of class, okay? No problem, no worries today, all right? Okay, so the range is simple, okay? The range just tells us the difference between the largest number and the smallest number, okay? So it just tells us how much of a range does our set of numbers cover. Okay, what is the range of our numbers? Well, it's just the largest number minus the smallest. Okay, sometimes books will write this as the maximum minus the minimum. Okay, so if you think back, we had two groups of students. We had the 7th graders, and their ages were 11, 12, 12, 12, and 13. And the mean was 12. And then for the K through 12 students, we had 8, 10, 12, 14, and 16. Okay? And again, the mean here was also 12. But if we look at the range, what is the range of ages for the 7th graders? 2. Okay, so our range here is 13 minus 11. I have a range of 2 years here. Alright? And that makes sense, right? Within an age group or 1 grade at school, most of the students are probably born within a 2-year span, right? For the K through 12, at least with these 5 students, what is my range? 8. Okay. So I do 16 minus 8. My range here is 8. Right? So what we see is this group has a larger range, and this group has a smaller range. Okay? More spread, less spread. The IQR is known as the interquartile range. Let's see.
The last one, right? This one. Yeah.
Okay, so what does the prefix inter mean? Inter, like interstate highway, inter means between, right? You learned this in school? No? Roots? Prefixes? Maybe? Okay. So this is basically the range between quarters, okay, between quartiles. You can think of this as the between quartile range. So this is, you're going to take Q3, the 3rd quartile, minus Q1, the 1st quartile. Okay. The range spans from the largest to the smallest. So the maximum to the minimum. It covers all data. The interquartile range covers from Q3 to Q1. So it covers basically the middle 50% of data. Okay, and it tells you the spread here. Okay, so so in our last in one of your data sets, you had the ages of students, and we found that Q1 was 8.5, I think, and then the other Q3 was 13.5. Is that right? Okay. So here our IQR, the IQR would be Q3 minus Q1. So I have an IQR of 5. So this week, as you we have a quiz next week. So as you